Okay, so looking at factoring, one thing about just the different types that we've talked about so far, and eventually we'll have give you guys a graphic organizer for the factoring and for the graphing stuff we talked about to kind of help you guys separate those out when you get those printed and give you guys access to those. We'll get there. So the first method of factoring that we learned was the GCF, the greatest common factor, and when do we use that? We talked about that you should always try this one first. There may not be a GCF, but you always just look because it's going to make the rest of the problem easier. Okay. And then we went to grouping. You know, what happened when we couldn't find a GCF? You know, was there still a way to factor it? And when we were able to do that was only when there's 4 terms. So we could break the problem into half. And then after grouping on Tuesday, we went to the AC method, which is probably the most important of the 3. And so what we saw with that is that it's mainly when there's 3 terms. Sometimes when there's 2. So why it's sometimes because it matters which term is missing. So it's based around having 3 terms. We can take out one of the terms and it'd be okay. So where that happens, and you guys don't necessarily write down this part, if I said something like 2x squared minus 50, if we think about what a, b, and c are, my a value would be 2, my b value would be 0 because there's 0 x's there, and then my c value would be negative 50. This is called the AC method. I have to have a c value and an a value in order to do it. So this one would be factorable with the AC method. If I did this instead, 2x squared minus 50x, then my a value would be 2, my b value would be negative 50, and my c value would be 0. And this one would not be factorable with the AC method because there's no c. You can't do the AC method if there's no c. So kind of when it's okay. So if b is 0, it's fine. If a or c were 0, we would not be able to do the AC method. So mainly it's for 3 terms though. Okay, so I want to do some factoring practice. And if you turned in that factoring homework, please go back and look at it. See if I made any comments on your work. See if there's like big things you need to change. So, okay. So it's going to kind of run through like how do I know when to do what, right? So we have three tools right now, right? And when we talk about was like when one of them stops working, how do we then progress? Okay. So the first thing I want to check is to see if with this factoring this is there something in common, right? So these all have x's, but this one doesn't. Right? And these 3 terms are all divisible by 2, but this one's not. Right? And these 3 terms all have a 3 in them, but this one doesn't. Right? So checking to see if there's a GCF. Okay? And no, there's not. Okay? So then what do I do? Right? How do I progress? Which tool do I reach for next? Okay? So what I would notice is that there's 4 terms. So what does that mean? Right? 4 terms means that we should go for grouping. Okay? So just how do I hit that logical progression? Okay, here, try this. Oh, that's not working. Okay, what's the next thing I try? Okay, see that there's 4 terms, we go to grouping. So grouping means split the problem in half. Okay, and we look at that first group. Now we go for a GCF within the first group. Say, what do the first 2 terms have in common? So both of those have 2 in them. They also both have 2 x's in them, so 2x squared comes out of both of those. Okay. Well, 2x squared times what is 6x cubed? No, 2x squared times 3x. And 2x squared times what is 8x squared? It would be 2x squared times 4, and positive 4, right? So I need a plus 4. And the next thing I want to do is look at the next group. And what do they have in common? And I want to notice here that that first term is negative. So when that first term is negative, we always take out a negative, so negative something. Okay? And then 9 and 12 both have a 3 in them, so we take out a negative 3. Can't take out an x because the 12 doesn't have an x. So negative 3 times positive 3x would be negative 9x, and negative 3 times positive 4 will be 12. Okay? Remember, grouping has a built-in check that these two binomials should be the same. Okay? And if they're not the same, then you're doing something wrong. You got to stop and figure that out. Or the problem is not factorable, which again, right now, we're not giving you any of those. Okay? So those are the same. So we take those two binomials that are the same and they go together. And then we take our leftovers, the 2x squared and the minus 3, and those go together. Okay. So now that we've written two sets of parentheses, okay, so I think there was one of you that I wrote on your assignment that you weren't finishing because you were stopping right here. Okay, so make sure you go all the way to this. If I said you need to finish these, that's probably what I meant. Okay, so make sure you go all the way to that. There's two sets of parentheses. Okay, and then we look inside the parentheses. Is there anything in common? 3x and 4, do they have anything in common? Nope. 2x squared and negative 3, do they have anything in common? Nope. Next thing I look for is, are there any squares left? Now this one has a square. Okay, so that's a hint that there might be more to do. And so we check to see if there's more to do. And so how do I factor this? Well, there's nothing to take out that's in common, so I can't use GCF. There's not 4 terms, so I can't use grouping. And so there's 2 terms, and so I say, well, maybe I can do some AC method. So we think about our A value would be 2. Our B value would be 0, since there's no X term. And our C value would be negative 3. So that means my AC, my A times my C would be negative 6. We need that to add to be 0. Well, our factors of 6 are 1 and 6 and 2 and 3. Well, I want negative 6, right? Well, is it negative 1 and positive 6? Is it positive 1 and negative 6? Right? Is there any way for me to get 0 out of these when I add them together? And there's not. So there's no way for me to take factors of negative 6 and add to be 0. So that means there's no way for me to factor that 2x squared minus 3. Which means that I'm done. Well, yeah, remember Clover, really depends on how the problem is written, okay? A is defined as the number in front of the x squared, and B is defined as the number in front of the x, and C is defined as the constant, right? If I had written it like this, if it was like that, then A is not the first number, right? A is the number that's next to x squared, and B is not the first number, the second number, B is the number next to x. So it really depends on how you write it. So generally, we write the highest exponent first, and then the next exponent, then we go on down like this, right? This is what's called standard form when the exponents decrease. So generally, it would be like that, Clover. But if it was like this, then C would be 3 and A would be negative 2. Okay. A is always the number next to the square, B is always the number next to the x, and C is always the constant. Does that make sense, Clover? Good question. And Camden, why is B 0, right? Because there is no B, right? There should be an x term like that. That would, if I was to get rid of this, let's see. Yeah. Okay. So here, Camden, A would be 8, B would be negative 9, C would be negative 12. Since we don't have an x term, it must be 0 x's. Does that make sense? Yeah, so why B was 0. All right, cool. Good questions? Okay. So what I'm showing you guys is, are there more layers to the factoring? That's something we're going to be working towards. This will there be more complex factoring problems. Not really something we're going to get into too much right now, but I just want to kind of introduce it. Okay, so I'm checking to see if I got all the things out I could. So is there still a GCF? And then if there's a square, I need to investigate that, right? Because remember what a square is. It's something to x times x. We're factoring. We're seeing what multiplies to be this thing we started with. Okay, Well, if I have x times x, there's a good chance that there's some multiplication happening there, right? So we're investigating that. Is there more to do? We found out that there wasn't. Okay. Remember, this should be equal to this. These two things should be equal to each other. This is just the factor version. Quick check you can do. 3x times 2x squared is 6x cubed. 4 times negative 3 is negative 12. There's a pretty good chance, not 100% chance, that if you got those two things right, that the middles will also work out. Now, you can still mess up the signs. It still can happen. And then these won't work out. But 3x times 2x squared is 6x cubed. 4 times negative 3 is negative 12. You're at least in the realm of possibilities. If you had like 4 and then like negative 5 here, for whatever reason, there's no way that gives you negative 12. There's no way that's right. Okay, so you can definitely see that the big error. So you can do a quick check without doing the full FOIL to see if your answer at least makes any sense at all. Okay. So first thing I want to do, check for a GCF. Okay. Do they have anything in common? Yeah. 5 goes into both of those, and there's an x in both of those. So I'm going to take out a 5x. 5x times x squared, and then 5x times negative 6. Okay, so I've taken out GCF. Now I notice that there's 2 terms left, so I can't do grouping. Okay, so I'm looking right here. 2 terms means no grouping, which means I could try AC. Okay, that's a question. Can I do AC? It's not always going to be yes. Okay. So my A value, my B value, my C value. So A would be 1, B would be 0 since there's no x's, and my C would be negative 6. So AC is negative 6. I need that to add to be 0. Right? A times C, that adds to B. So factors of negative 6, 1 and 6, 2 and 3. Is there any way for me to get 0? All right, looking at a very similar problem to the last one. There's no way for me to get 0 again. Okay. It's funny that we had the same AC and B value again, even though we had completely different numbers we were looking at. So that is not factorable also, so that means we're done. Again, what we have here is equal to what we have here. We're just pulling it apart. And we're undistributing that word. Okay? And we're not simplifying when we factor. If you're ever asked to simplify a problem, you should not be factoring. And we're actually making the problem more complex by doing this. Any questions on the second one? A couple more. Always look to see if there's a GCF first. 7, 26, and 8. 7 does not go into 26. Okay. Nothing. So there's nothing in here to do as far as GCF. They don't all have x's or anything like that. Okay. So then I see 3 terms, which means I should try AC. Okay. My A, my B, and my C. So AC is 7 times negative 8, which is negative 56. I need that to add to 26. Okay. Again, this notation right here is kind of something that I do. You probably won't see that anywhere else. But everything after that is pretty standard, okay? As far as what you should be asking yourself. And again, this kind of little, almost like little chart that I make, I think I don't know if I've ever seen that really on a video or anything like that, where I looked at stuff online, so you may not see that. But what we do with those numbers that we find, you guys will see, and we repeat it in different methods or different versions. Other people doing the same thing. Okay. So again, are you familiar with your factors of negative 56 that are going to add to be 26? Some of you might see it. Most of you probably don't. Okay, so how do you figure out what numbers multiply to be negative 56 and then add to be 26? Let's just start with 1. 1 times what? 1 times 56. You just start dividing, right? 2 times what? So you go to your calculator. Okay, 56 divided by 2. Okay, 56 divided by 3. Remember, you're only writing down integers. Okay, so 3 is not going to work, right? 56 divided by 4. Okay, so 2 worked. 2 times 28. 3 does not go into 56. 4 went in 14 times. 5 does not go in 56. 6 does not go into 56. And I just know, right? 3 didn't go into 56, so 6 can't go into 56. 7, well, that goes in 8 times, right? We already saw that. That's where we got 56 from. Here's our loop. This tells me that I don't need to go any further because I already wrote down 8. Okay, so these are all the factors of 56. But I need negative 56, which means one of my numbers needs to be negative. I need negative 56 to get positive 26. So negative 2 and 28 will give me 26. Okay, so those two numbers multiply to be negative 56, but add to be 26. Okay, it's unique. There's no other numbers that do that. Got to find that right combination. So how I write that little chart that I write, that's kind of my own thing. Okay, what we do with those numbers is the same that everybody else does. So that's 7x squared. That comes back. The negative 2x, the positive 28x, and then the negative 8. Okay, 7x squared, negative 8. And what the AC method is all about is how to break this number here apart. What do we do with that 26? How can we break it apart in a very unique way? There's only one way to do this correctly. All right, negative 2 plus 28 is 26. Right? These two things are equal. Right? So now we have 4 terms. Right? What do we do with 4 terms? We go to grouping. Okay? The AC method is all about how to take a 3-term problem and turn it into a 4-term problem. 7x squared and 2x both have an x in them. X times 7x and x times negative 2. 28 and 8 both have 4 in them. That's a positive 4. Now, there were quite a few people that were not putting these plus signs here. And if you don't do that, I am going to be taking points off of that. And that is something that I look for. And that plus sign has to be there. We saw it here with the minus sign. People are usually pretty good about putting the minus sign there. You have to put the plus sign also. This cannot be, when you put a number next to parentheses like that, it implies multiplication. This needs to be addition. 4 times 7x and 4 times negative 2. These are the same, so we got that built-in check. So those 7x minus 2's come together, and then our leftovers come together, x plus 4. Once you have it broken into the 2 sets of parentheses, you go back inside. Do these have anything in common? Do these have anything in common? No to both of those. Do I have any squares? No to that question. Okay, so I should be done. I can quickly check to see if my answer makes any sense at all. I don't have to check the whole thing. Okay, again, doesn't mean I'm right, but at least see if I make any sense. 7x times x is 7x squared. Negative 2 times 4 is negative 8. There's a good chance that this will happen. What could be wrong here is if I put plus 2 and then minus 4, that would also give me negative 8. But then the middle wouldn't work out. Okay? So you can still get it wrong, but at least we see that it does make some sense. It's not completely bonkers. There's nothing left in common. No more squares. Tells us that we're done factoring. And we probably got it right because we did a quick check. So there's AC method. Yeah, again, that's probably going to be the most important type of factoring that you guys learn. Okay. Anything on that one you guys want to talk about? Let's look at this last one. 18x squared minus 50 for GCF. Both of those are even, so they both have 2 in them. 2 times 9x squared, and then 2 times 25. Okay. So they don't have anything in common anymore, but there's a square. So can I do more? So now I look at that and I say, can I do AC method on this? A is 9, B is 0, C is negative 25. So 9 times 25 is 225. We have to add to 0. Okay. It's a pretty big number, which means we're probably going to have a long list of factors to look at, unfortunately. We always start with 1, times 225. 2 will not go into that, okay? So what I know right off the bat is that any even number won't go into this, okay? Because 225 cannot be divisible by an even, so I can skip all of those and make my list a little bit shorter. 3, so check 225 divided by 3. 75, all right? 225 divided by 5 on here. And 225 divided by 7. All right, 7 doesn't work. So 3 is 75, 5 is 45. Seven didn't. 9 will go in 25 times, right? So 9 times 25. 11 will not go into it. Just know that. 13 won't go into it. I just know that. 15 goes in 15 times. And so there's our loop. Okay, we hit that perfect square. 15 times 15 is a perfect square. Okay, so I don't need to do any more. There's 16, 17, those won't go into it. Okay, so I'm done getting factors. I need negative 225 though, which means one of them needs to be negative. Right? So but I need to get 0 as my sum. Well, negative 15 and positive 15 will give me 0. Sorry, I came down and see that earlier. Okay, so I can factor this. I can find factors of negative 225 that add to be 0. So this is factorable. So what I'm going to do is go back up to here. Plus 15x. Now this one's a little weird, right? Because there's nothing in the middle. Remember 0x though. So I have to write 15x, not just 15. 15 won't work. And minus 15x. And then minus 225. Or 25, sorry. Okay? So I took that 0x and I broke it into a 15x and a negative 15x. It has to be 15 though, it can't be any other number, or it's unique. Okay? I gotta be really careful, I don't want to lose that 2. As I do this, I don't want to lose that 2. Break in half. 2 is gonna hang out outside. 9 and 15 both have 3 in them, and an x. 3x times 3x is 9x squared. 3x times positive 5 is 15x. This is negative, so I'm going to take out a negative. Both of those have 5, and I'm just going to take out a negative 5. Negative 5 times positive 3x, negative 5 times positive 5. Give me 25. And I need to close that red set of parentheses. And don't lose your 2. Is what's inside the parentheses the same? Sure is. And I have my leftovers. So the 3x plus 5, those go together. And then the leftovers are 3x minus 5. Those go together. And then we have our 2. This is the first time you guys have seen a problem like this, where we had a GCF and then an AC method. Okay? So this is a little bit higher on the complexity level. Okay? Am I done? Do these have anything in common? No. Do these have anything in common? No. Are there any squares? No. So we should be done. Okay? Is it right? How do I know? How do I even have a chance? 2 times 3x is 6x. Times 3 is 18. One more x, 18x squared. Okay, that part's right. 2 times 5 is 10. times -5 would be -50. That part's right. And then I hope that the middles would work out. Okay? But at least I know the beginning and the end are right. Okay? Again, if you mess up a sign, that can mess up stuff in here, okay, as far as the middle goes. But at least you got most of it right. Okay? If you really want to check, you could sit there and FOIL it all out. Okay? And sometimes we will ask you guys to do that, check your answers. But at least it seems to make sense. I know it's not junk. Okay. So this is a type of factoring here. We actually could have done this a lot faster with a new tool that we haven't learned yet, which we're not going to learn today. But what it's going to require you guys to know is some of your perfect squares. So this one really keyed in on that this was a perfect square. Okay, that 15 and 15. But if you didn't know that 225 was 15 times 15, you can't do it. So something we'll be asking you guys to do later is to know your perfect squares through 15. So what's 14 times 14? What's 13 times 13? Just to know those. Then that'll help you out. Camden, 3x minus 5. Where is the x? Which x are you talking about, Camden? This x? It's right here. And the minus 5 right here. So those two pieces go right here. These two that are the same go together here. So same thing that happened here, right? The x and the 4 go here. The 7x minus 2 is here. And it doesn't matter. You can write it like this also. X plus 4, 7x minus 2. Those things are the same. The order that you write the two chunks in doesn't matter. But within the chunks, I can't take the 4 and the x and switch those. I can't take the 7x and the 2 and switch those. But I can take the two pieces and that with them. That doesn't matter. Because that's multiplication. Right? Just something times something else. It doesn't matter the order you do them. Same thing here. I could rewrite this. That could be 2 times 3x minus 5 times 3x plus 5. That's the same thing. We could also put the 2 in the middle or something like that. But you guys should notice that that doesn't feel right. Putting a 2 right there in the middle. We don't do that. We have just a single term like that. We always put it in the front. So that's not okay to do. Even mathematically it's fine, but we don't do that for our heads, for our eyes. So. All right, so that's a little review of factoring. Again, something we're going to keep working on, and we're going to add more tools to your toolbox there. But the main point today is to get to the last form of the quadratic equation, which is called our intercept form. If you want to do the sketch, you can. You don't need to. I don't know why their little line is not dashed. Should be. But you definitely would write down the stuff that's in the words. You don't need to do the sketch if you don't want to. So this is called intercept form. So it's y equals, or f of x equals a, right? There's our good buddy a, x minus p times x minus q. Okay, so there's our new form, x minus p times x minus q. So why it's called the intercept form is because it tells us the x-intercepts. You know, we had vertex form, which told us the vertex when we looked at it. Standard form didn't tell us too much, but we could see that we did see the y-intercept was sitting there at the end of the problem. So this tells us the x-intercepts. And so those x-intercepts are p, 0, and q, 0. So what you need to notice here is that there are sign switches. So just like H line lied to us, P and Q also lie to you. Okay? If that said x plus 3, then this would be negative 3, 0. If this said x minus 4, this would be positive 4, 0. Okay? So as we pull the numbers out of here, out of the problem, we switch their signs. Okay? That's the only sign switch we make. We have to pull it out. Okay? The axis of symmetry is halfway between those two things. That's a pretty important thing. Okay? But there is a formula if you want. Okay? So there is a formula for this. It's x equals p plus q divided by 2. So all you have to do is take the p value and the q value after you switch the sign, add them together, and then divide by 2. It's just averaging. That's all it is. Okay? You're just finding the average. You're finding the middle. P plus q divided by 2. Okay? That's what P and Q do. All right, what's A's job? Well, one of its job is to flip the graph upside down or not. Okay? So A opens up, or the graph opens up if A is greater than 0, right? That's positive. Or if A is less than 0, the graph opens down. But that's nothing new. You guys should already know that. Okay? Brooklyn, are you trying to say something?
No, sorry.
All right, checking. Does anybody need more time here? I'm just going to take this and we're going to graph with it. Graphing is going to be pretty similar to what we've been doing. We've already graphed from 2 forms. It's really not too much different with this form. Anybody need more time? Okay. All right, so we're going to graph this guy. Pretty much what your homework's going to look like as far as, again, I'll ask you guys if you didn't finish your factoring worksheet, make sure you do that. Then you have 3 problems that you're going to graph from intercept form. Okay? I'll ask you to do these same things here, and I'll ask you also to find the domain, the range, and the min or max, like we've been doing. So, okay. But again, I would like you guys to do your work on the left side, and then have your graph right next to it on the right side, or vice versa. So again, we are going to get to a point where we do a graphic organizer to help you guys pull this apart. Like, which form am I looking at? What do I know? What do I need to do? Okay. But remember our vertex form. You don't necessarily write this down. It's y equals a times x minus h squared plus k. And then the standard form was y equals a x squared plus bx plus c. So how do I tell the forms apart? Vertex form is the only one that has parentheses with a square on it. Notice there's no square on these parentheses. Notice here there's no parentheses. So vertex form is parentheses with a square. Standard form, there's no parentheses at all. Okay. Intercept form, there's generally two sets of parentheses. There is a way to write it with only one. Okay, but there will never be a square. So intercept form is the only one that doesn't have a square. That's the best way to know that it's intercept form versus one of the others. This has a square, this has a square. There will never be a square here. Most of the time there's 2 sets of parentheses. There is a way to write it with 1, so that's not the best way to indicate it. Okay? Square on the parentheses, vertex, no parentheses, standard, no square, intercept. Okay? Which form am I looking at? How do I progress? Because if I use the wrong ideas, if I try, oh, there's my vertex, you look at this, there's my vertex, you're screwed. Okay, so what are you looking at to say? Like, here's what I should be seeing. So first thing I want to do is look at the intercepts. So I make sure that I switch the sign. That says -1, so it's +1, 0. That says +5, so it's -5, 0. Okay, so sign switches. Okay, so just pulling numbers out though. It's pretty easy. I'm gonna go ahead and plot those 2 points. So there's my 2 points. Then I have find the axis of symmetry. Remember, there is a formula for this: x equals p plus q divided by 2. Okay? The more you write it down, the easier it is to remember. So something plus something divided by 2. All right, my p-value. Remember, we already switched the sign. Don't switch it again. It's 1. And then my q-value is -5. Okay? So we'll bring those straight down. 1 plus -5 is -4. -4 divided by 2 is -2. X equals -2. So definitely one of the easiest things to do, right? I keep harping on this is about the signs. Is if you change the signs again, or if you forgot to change the signs. Okay, so you do -1 plus 5, right? -1 plus 5, that would give you +4 over 2, which would equal 2, which would put the axis of symmetry over here. Notice how the axis of symmetry is not between the intercepts. And the axis of symmetry is supposed to be the middle of the graph. It doesn't make sense if that's not in the middle, right? So you technically actually don't even need the formula to find the axis of symmetry. If I just look at where this is and say, well, where's the middle of these 2 points? I should be able to tell that it's at -2. One time it gets really tricky is if it's sometimes the points are an odd number away from each other, and so then the middle is a decimal. It's a little tricky there. But for most of the part, guys, it should be pretty easy to tell where the axis of symmetry is, just with your eyes. You don't need a formula for that. Just like standard form, as soon as we have that x value, we plug it in to figure out what the y value of the vertex is, because remember the vertex is somewhere on that line. Right? So we know the x value of the vertex, we need to find the y value. So we're going to find f of -2. So 1/3 -2 minus 1, -2 plus 5. Do not sit here and try to FOIL this out. You're going to drive yourself nuts. Okay? You're simplifying this, which means you're just doing order of operations. You do what's inside the parentheses first. So I'm going to start here, which equals 1/3 times -3 times +3. This is all multiplication. 1/3 times -3 times +3. So I get to choose which multiplication to do first. You can't do all of it at the same time. You can choose which two to do first. So I'm going to do these two first. Okay? Which is 1/3 times -9. 1/3 of -9 is -3. -9 divided by 3 is -3. Means my vertex is at -2, -3. So I'm going to go plot that point. You guys all good how I found the vertex, how I found the axis of symmetry?
Yep.
I'm not okay if you guys just have numbers written down. Oh, x equals -2, no work shown. And on that one, there's actually a way to do it without doing work, so I'm okay with that. Not okay if you just have -2, -3 written down without showing me how you got that. Okay? Some of you guys are just writing down answers, expecting me to be okay with that, and I'm not. Okay? You need to show me where it came from. Okay? So we have 3 points, right? I've asked you guys to find at least 5, so we need one more that we can reflect to get our 4th and then 5th. just like with the standard form, what you guys need to do is stop and think. Okay? This is no more prescribed. Find the x-intercepts, do this. Find the axis of symmetry, do this. Find the vertex, do this. Now we got to stop and think. Okay? What do we already know? Right? Our job is to put in x values. What x values do we know? Well, we just found if x was -2. We also know what the value of -5 is. It's 0. And we also know the value of 1. I'm just looking at these x values that I already have. I don't want to do that math again. It'd be a waste of my time. So what x values don't I have? Okay. There's some numbers here that we don't know. Okay. Like -1 or 0 or -3 or -4. So any of those would be fine to use as our 4th point, which we can then reflect to get our 5th point. So you get to pick, which number do you want to plug in? And I look at that and I say, oh, 0. I like 0. I have 0z. So 1/3 of 0 minus 1 times 0 plus 5.
Wait, where did you get the green and blue points that you've already plotted? Okay.
Let's bring the numbers down, Lily. Right? That's why it's called intercept form, because it tells us the x-intercepts. You good?
Yes.
Okay. So again, I get to do this math in the order that I want to do it, or not the way I want to do it, sorry. Start inside the parentheses. So 1/3 of -1 times 5, which is 1/3 of -5. Okay. So I don't know what 1/3 of 5 is. So get on my calculator. 5 divided by 3, 1.666, right? Just round that to the nearest tenth, so 1.7. And I go and I plot that point. So 0, 1.7.
Is that a negative?
Shh, ruining it. So yeah, so I flip it, right? And it should be over here. And I go to draw my graph. It does this. And I go, that's not a parabola. What did I screw up? Okay. And just like Jet said, it's supposed to be negative 1.7. Okay. So seeing that you're not drawing a parabola should be a big hint. Okay. So I go to 0, negative 1.7. Whatever you read about, oops. Right about there. Go 2 to the other side. All right, this is 2 away, so go 2 to the other side. Now, as I connect that, it looks like a parabola. Should not go straight up. Right? It doesn't go straight up like that. You should have arrows on the ends of your graph. Not expecting you guys to, especially with some of them where it's difficult. I'm not expecting you to continue the whole way up. I'm not expecting, all right. I'm not expecting that, but I'm expecting some continuation beyond that last point. I'm expecting arrows. Again, it should not go straight up. It should not bell out. It should be a smooth curve as it continues to slowly expand out. Okay. But missing a sign, right? Big deal. But it should be obvious when the sign is off that something isn't right. It's no longer a problem. Right? That stuff should be obvious. And when if your numbers get really big, like all of a sudden I'm trying to plot like 0, negative 25, it should be something telling you, hey, you messed up somewhere. Okay? Signs are such a big deal with this stuff, right? All these sign switches. Right? You forget to do that, things are going to get real weird real fast. Okay? So let the work talk to you. Okay? If your numbers are getting too big, if your graph is not a parabola, something's going to be wrong. Okay? It's going to let you know.
So why did we pick 0 to use as another point?
Do you understand where I got the purple numbers from?
Just the numbers that are in between the -5 and 2.
Yeah. So, it's our job to pick. So I picked the one that I thought would be easiest, silly.
Okay.
I thought it's
Okay.
like 0, right? Why wouldn't I use 0? Right?
Okay.
We can use -1, we can use -3, -4, but it doesn't matter. Those are just the choices we should make. We know the -5, we know the 2, -2, we know the 1. So what are the things around those that we don't know?
Okay.
We could also use like +2, that's getting pretty far from the vertex. We might get ourselves in trouble. It might be too big by then. So you want to stay close to the vertex, but fill in the gap here, right? Other than that, I'm just picking the one that I thought would be easiest. Good question. Do you guys need me to go over min-max, domain range? I think you got that. I'd like to do one more here with our last 5-6 minutes. Same steps. Okay. New function. But with any of the graphing guides, it's about what is it giving me, right? How do I take advantage of what it's giving me? Do I have the vertex? Because the vertex is the most important part, right? So if it's vertex form, boom, I got vertex. The other two, okay, how do I find the vertex? And then what else do I need to fill out the rest of it? Okay, they've all got their gives and their takes. With the vertex form, they give you that most important point, but then you have to do more math to find out the rest of it because they only give you 1 point. The standards, they give you the y-intercept, which you can usually reflect to get 2 points, and then you got to find the vertex, and then you got to find more after that. This one, they give you 2 points, find the vertex, find one more after that. So they're really about the same. It's just been paying attention to what you're being given. Making sure you find the vertex afterwards. So do that sign switch. We got 3, 0, and then -1, 0. So plot those points. Remember, you can use the formula or not. Okay? I don't need the formula to find the axis of symmetry. The axis of symmetry is the middle. Okay? Those are 4 apart. That means the middle should be 2 apart. Right? So the middle should be 2 away, which would be at 1. So x equals 1 should be where my axis of symmetry works out to. I can check that with the math, but I should know the answer already. Okay? X equals p plus q divided by 2. 3 plus -1. 3 plus -1 is 2. 2 divided by 2 is 1, right? X equals 1. Why did I write -1? Good word. Okay, so matches up. Again, you don't need it. Okay, you don't have to memorize that formula. The negative b over 2a, you got to know that. There's no way to trick that out. Okay, this one has to be worked out this way. We take that 1 and we plug it in. -2 times 1 minus 3 times 1 plus 1. We're simplifying this down. Okay, so do the parentheses first. -2 would be -2 again, +2. Negative times a negative is a positive. 2 times 2 times 2 is not 6, it's 8. So our vertex is at 1, 8. So there's our most important point, 1, 8. So we've got 3 points. We need 1 more to flip. Okay. So what do I know? I know 1. I know 3. And I know -1. What's missing? Okay. So I'm just looking at those x values. 3, -1, and 1. Just wrote them down like in a number line. 0 is missing. 2 is missing. We get a pick. So I'm going to do 0 again. Don't forget that -2. Again, you're just doing some, this one's pretty easy. -2, 0 minus 3 is -3, 0 plus 1 is 1, -2 times 3 is 6. Okay? So 0, 6. Flip it over to the other side. Does it look like a parabola? Right? If I go to connect it, does it look like a parabola? Okay. It's not bending, it's not a V, it's definitely not a straight line. Okay. Has a max value since it's upside down. Domain, right? It's always all real numbers. Our range, that goes down forever, so it's negative infinity. Max is out at 8. That gets a bracket on that 8. Okay. On homework, I'm asking you guys to do the max or min. The domain range. Okay.